In this video, we're going to solve another system of linear equations, but we have to set up the system first before we can solve it. So this problem is for my nursing students. Here's a really nice problem. Let's suppose that a doctor's prescription calls for a daily intake of 40 milligrams of vitamin C and 30 milligrams of vitamin D, right? However, the pharmacy stocks only 2 liquids that you can use to fill this prescription. So one of the liquids contains 20% of vitamin C and 30% of vitamin D, and the other liquid contains 40% of vitamin C and 20% of vitamin D. So the question that you want to answer is, how many milligrams of each of those types of liquids should you mix together so that you can fill the prescription called for by the doctor? Okay, so let's break this problem apart, okay? The first piece of information that we have is we know that the doctor is calling for, so I'll write down here, the doctor is calling for 40 milligrams of vitamin C, so I'll just call that, let's see here, vitamin C. We need 40 milligrams, okay, and for vitamin D, we need, 30 milligrams. Okay. All right, so we gotta meet this requirement here for the prescription. We need 40 milligrams of vitamin C, 30 milligrams of vitamin D. Now let's take a look at what we have at the pharmacy. So at the pharmacy, we have 2 liquids. So I'll call it liquid solution 1. So I'll call that X, okay? And then we also have the liquid solution 2, and I'll just call that Y, okay? All right, so in the first solution, we have 20% of vitamin C, so only 20%, okay, of this liquid. We don't know how many milligrams of this liquid we're going to use, but we know that 20% of it is vitamin C. Vitamin C. Okay? All right? And 30% of it, so I'm converting this to decimal, 30% of liquid 1, however much of liquid 1 we're going to use, contains vitamin D. Okay. All right, now the second liquid that we're going to mix with this first liquid contains 40% of vitamin C. So 40%. So I'm keeping it in this row here. This row right here represents vitamin C. Okay. And it has 20% of vitamin D. So that's my second row. I know that when I combined liquid 1 and liquid 2, right? However many milligrams of liquid 1, how many milligrams of liquid 2 I take from each solution, I need to make sure that altogether I end up with only 40 milligrams of the vitamin C. Okay? For the vitamin D, however many milligrams of the first liquid that I combine with the second liquid, I need to make sure that together I'm only going to gather 30 milligrams of vitamin D to fulfill the prescription set by the doctor. So notice what we have here are 2 equations, right? My first equation represents how much I will mix of both liquids to get 40 milligrams of vitamin C. My second equation represents how many milligrams of each liquid I will mix to get 30 milligrams of vitamin D. So now we have a system of linear equations. Again, I'm going to use an augmented matrix to solve this system. Okay? So I'm going to set up my matrix by writing down the coefficients, right, in front of each variable in both of my equations. So I'm going to call my first row I'm going to have those coefficients represent the coefficients in front of x, which is liquid 1. And then my second row will be the coefficients in front of all the y terms. I just realized I have a typo here. This should be y. Okay. So again, my second column is going to represent all the coefficients in front of my y terms for liquid 2. And then, of course, we have our constants in the last row. Okay, so we've got 0.2, 0.4, and 40. And we have 0.3 and 0.2 and 30. Okay, now I'm going to go to my calculator and row reduce these rows into echelon form to get it into a matrix that is row reduced like this. And then, of course, we'll have our solution here and here. Okay, again, first column representing x, second column representing y. The leading coefficient in the first column will give us the solution for x, right? The leading coefficient in the second row corresponds with y, so that will give us the solution for the y variable. Okay, I'm going to pull out my graphing calculator here, and let's go into the matrix function. So I'm going to press second matrix. First thing I'm going to do is I'm going to edit my matrix, and I'm going to go ahead and just choose matrix A here. It's already set up as a 2 by 3. Okay, now I'm just going to type over the old problem that I was working on. Okay, so 0.2, 0.4, 40, 0.3, 0.2, 30. Right, now that I have my matrix, I'm going to get out of this window, go back into the matrix, and now I'm going to perform the RREF, which is reducing the rows into echelon form. So scroll down to B. Okay. And then I'm going to go back into my matrix and choose matrix A under the tab called Names, and have my calculator find the solution for me. So this is telling me that my first row is 50, my second row is 75, so this is 50, 75. Now let's interpret our answer. So again, the leading coefficient here in the first row corresponds with x, so this tells us that we are going to end up using 50 milligrams of solution 1, or liquid 1. And then this second row tells us that we're going to use 75 milligrams of liquid 2. Okay? So based on what we know about how much vitamin C and vitamin D is in each liquid, we're going to pull out 50 milligrams of liquid 1 and combine it with 75 milligrams of liquid 2 to fill a prescription that calls for 40 milligrams of vitamin C and 30 milligrams of vitamin D.